Hello guys, this is a review of Series 5, Page 1 of the Countdown to Math Star. Question 1. Mr. and Mrs. Sue write a tally mark on a clipboard each time they jog 15 miles on a treadmill. Okay, what this means is that each one of these tally marks represents the number 15. Okay, so on Mr. Sue's clipboard, he has 5, 10, 15, 16, 17, 18 tally marks. Okay, what that means is he has 18 of the number 15s and so on, okay? So kind of picture that in your head. That helps you notice that what you're doing is you need to combine all of those 15s to find a total, okay? We call that repeated addition, okay? But it would take us too long to try and add all of those 15s together, so we use multiplication, okay? So I'm going to take the 18 tally marks and multiply it times 15 miles per tally mark. 5 times 8 is 40. 5 times 1 is 5, plus 4 is 9. I'm done with the 5. Scratch it out, lay that 0 down. I'm going to get rid of anything that I carried. 1 times 8 is 8, and 1 times 1 is 1. Okay, so I'm done multiplying the 1 by both, so I'm going to combine these two rows. Carry that 1. Okay, so Mr. Sue has jogged 270 miles. Okay, now we need to do the same thing for Mrs. Sue. Okay, so she has 5, 10, 11, 12 tally marks. So we're going to multiply her 12 tally marks times 15 miles each. 5 times 2 is 10, carry the 1. 5 times 1 is 5, plus 1. It's going to give you 6. I'm done with the 5, so I scratch it out, lay that 0 down, get rid of anything you carried. Okay, 1 times 2 is 2. 1 times 1 is 1. I'm done multiplying that 1, so I'm going to combine these two. That's 0, that's 8, and that's 1. Okay, so Mrs. Sue has jogged 180 miles. Okay, the question is asking us to find how many miles they've jogged combined. That tells me that I need to add those two numbers together. So I'm going to take 270 and add 180 to it. Okay, that's going to be 15, and that's going to be 4. So together they have jogged a total of 450 miles. Okay, question 2. All right, this is what we call an elapsed time problem. Okay, we're talking about how much time has elapsed or gone by. Okay, so there are 3 parts to an elapsed time problem. We have a start time, we have an end time, and we have the elapsed time, how much time has gone by, okay? So in this problem, it says Dylan began reading at 3:15 p.m. Okay, so that's gonna be our start time. Okay, he stops reading at 5:35, that's my end time. So we're trying to find how much time elapses in between, okay? There are so many different ways to do an elapsed time problem, and I tell kids, whatever method you use, as long as you get it right, I don't care, okay? But a simple way to look at it for those kids that struggle is to use a mountain for hours and use a hill for minutes, and to set it up kind of like a number line, okay? So I'm going to start over here with my start time, 3:15, okay? I see that going from 3:15 to 5:35, there are a couple of hours in there, okay? So I'm going to use my mountain for 1 hour. 1 hour past 3:15 gets me to 4:15, okay? So I'm getting closer, okay? I recognize that I can go another hour because 1 hour past 4:15 gets me to 5:15. But if I added on another hour, that would get me to 6:15, and I can only go to 5:35, okay? So now I need to use a hill, and I'm going to try and figure out how many minutes it takes to get from 5:15 to 5:35. Well, I know it takes 15 minutes to get from 5:15 to 5:30, and 5:35 is just 5 minutes past that. So 15 plus 5 is 20, so I'm going to add on 20 minutes, okay? And that gets me to 5:35. Okay, now our question says, how many minutes elapsed between these two times? Okay, so we have to be very careful when we're reading those questions to make sure we pick up on that. Okay, so I want this in all minutes. I have it in hours and minutes. So I need to take these 2 hours and I need to change them into minutes. Okay, so you have to know, and you can also find it on your STAR chart, your STAR resource chart if you have it, that 1 hour is equal to 60 minutes. Okay, so I have 60 minutes for this first hour, another 60 minutes for the second hour, plus an additional 20 minutes. Okay, those are zeros. 6 plus 6 is 12, plus 2 more is 14. So it takes 140 minutes to get from 3:15 to 5:35. Okay, to put that in the grid, it's going to go to the left of the decimal because these are whole minutes. Okay, it's not going to be a decimal. So I put in my digits and then I need to bubble those in. Okay, number 3. What is the name of the figure shown here? Okay, well, right off the bat, I can tell this figure has 4 sides. Okay, a 4-sided shape is called a quadrilateral. Okay, now we have special quadrilaterals that we can classify based on their parallel sides, if they have any parallel sides or not. Okay. Answer choice A is a rectangle. A rectangle is a special kind of quadrilateral. It's also a special kind of parallelogram because it has 2 pairs of parallel sides. But another thing that we know about a rectangle is that it has 4 right angles. Okay, this does not have 4 right angles, nor does it have any parallel sides. Okay, so it cannot be A. Okay, and the reason that I say it doesn't have any parallel sides, at first glance, it might appear that these 2 line segments are parallel to each other, but they've put this kind of grid paper behind it so that you can see that this top line segment here is starting to dip down just ever so slightly as you move to the right. In order for line segments to be parallel, they have to be the exact same distance all the way across or all the way up and down. Okay, so here, you can see the distance from here to here. It gets us, we go through 1, 2, 3, 4 squares. But over here, you go through 1, 2, 3, and then about 3/4. It's not exactly the same, okay? So that means that this side is dipping down just a little bit. And as that happens, they get closer and closer together as you move off the paper, and eventually they're going to intersect, okay? So this figure has no parallel sides, okay? So knowing that, I also know that it can't be a trapezoid because a trapezoid has 1 pair of parallel sides, okay? And this has none. Okay, C says parallelogram. Again, it can't be a parallelogram because there are no parallel sides. Parallelograms have 2 pair of parallel sides. The answer is actually D, and what we call this is a non-specific quadrilateral. Okay, that's just a general term for a 4-sided shape that doesn't have any parallel sides. Okay, so that's what that one is. All right, number 4. Which pair of fractions are equivalent or equal to each other? To figure this out, all I'm going to do is I'm going to use cross products or the butterfly. Okay, so I'm going to multiply 12 times 3, which is 36, and 4 times 6, which is 24. Okay, the number 36 is greater than the number 24, so that means that 3/4 is greater than 6/12. They are not equivalent to each other, so it cannot be F. Okay, for G, 16 times 3 is 48, and 4 times 9 is 36. 48 is greater than 36, so that means the 2 are not equivalent. Can't be G. H, 12 times 3 is 36. 4 times 9 is also 36. Those 2 are equivalent to each other. J, 9 times 3, 27, and 4 times 6 is 24. 27 is greater, making 3/4 the greater fraction, and they are not equivalent. So our best answer is H. Number 5. Okay, these problems seem to give kids fits. And we understand input-output tables, but when they start to put expressions in a sentence like this, it really starts to get confusing. So I'm going to show you a way to kind of simplify that and make more sense to you. All right, so Kara wrote a series of numerical expressions to generate a number pattern. Okay, so each one of these is its own expression. 50 minus 1 is its own. 50 minus 2 is its own expression. And 50 minus 3 is its own expression. So you have 3 expressions there. Okay, so typically in an input-output table, here's what you have. You will have 3 columns. One to the far left is for your input. The one in the middle is for your expression, which is also the rule. We'll also give you the rule for the input-output table. And then to the far right, you have the output. Okay, so here's how an input-output table works. It works much like the coin machine at Chuck E. Cheese. Okay, so you put money into that machine, it does something inside the machine, and it spits out coins. Okay, that's kind of like an input-output table. You plug a number in, something happens to it in the middle, and it spits another number out. Okay, the importance of the expression column in the middle is that that expression box is where you're going to find the rule for the input-output table. The rule is what you're doing to the input that will give you the output. Okay, well, if you look at your answer choices over here, they only have the input and the output listed. They don't have the expression. Okay, so what I'm going to do is I'm going to take the expressions that are in the list up here and I'm going to fill them in so that we can find the rule to see what I need to apply to these input-output tables to find which one is correct. Okay, so I'm going to put these expressions in. So I have 50 minus 1, 50 minus 2, and 50 minus 3. All right, so the input for the first expression is going to be the number 1. I'm just getting that from right here. Okay, the second one is going to be 2, and then 3. Okay, so now I'm going to solve each expression. 50 minus 1 is 49, 50 minus 2 is 48, and 50 minus 3 is 47. Okay, so this is how our input-output table should work. Okay, here's my rule right here. This is what is staying the same in each expression, the 50 and the subtraction sign. Okay, so what I need to do is I need to come over here and use that rule on these input-output tables to see which one of these matches using that rule. Okay, so what I'm going to do on my answer choices over here is I'm going to kind of draw in my own middle column here to write my expressions. Looking for my other paper. Okay, sorry about that. I had to grab my other paper. Okay, so for A, I'm going to take my rule of 50 minus the input. I'm going to plug it in. 50 minus, my input is 8. Okay, 50 minus 8 gives us 42, not 40. Okay, so I know that A cannot be my answer choice. Okay, now B says, let's plug in 50 minus 9 here. Okay, 50 minus 9 does not equal 46. That equals 41. Okay, that proves that answer choice B cannot be our answer either. Okay, now for answer choice C. Okay, take my 50 and my subtraction sign, plug in the 11. Okay, 50 minus 11 does give us 39. Okay, so now I've got to check it with the rest of the parts of my input-output table to make sure they are correct. Because sometimes they'll give us the correct rule for the first input, but then it won't work for the rest of them. So we've got to make sure it works for all of them. Okay, so I'm going to put my 50 minus 24, which does equal 26. Okay, now 50 minus 35, that does equal 35. Okay. Now, answer choice D. Okay, 50 minus 12 equals 38, not 32. Okay, so that tells me that answer choice D is not my answer either. Okay, so my best answer here is C, answer choice C. All right, number 6. The table shows the number of laps that 3 students ran around the track at recess last week. On which day of the week did the 3 students run the greatest number of laps combined? That means I'm adding. Okay, so on which day of the week? So that means I need to look at each week and combine their numbers and find which week had the greatest number. Okay, and I've kind of already gone through this just to kind of speed things up. Okay, so for Monday we have 29. Tuesday we have 32. Wednesday we have 30. Thursday we have 30. And Friday we have 29. Okay, so the greatest number of all of those is going to be this 32, which is for Tuesday, which would be answer choice F. Okay, and last, number 7. Before a soccer game, Alex drank 5/10 of a liter of water. Jada drank 45/100 of a liter. Anna drank 6/10 of a liter. And Neil drank 65/100 of a liter. Which table represents this information? Okay, so we just need to match up the decimals to the fractions. Okay, so Alex drank 5/10. A shows that, B shows that, C shows that. D does not. D shows 5 whole liters plus an extra 1/10. Okay, so it cannot be D. Next, Jada drank 45/100. Okay, cannot be A because it's showing 4 whole liters. Okay, so that marks out A. Again, right here, 4 whole liters. Can't be our answer. Here we have 45/100. That's correct. Now, Anna drank 6/10. Yes. And Neil drank 65/100. Yes. So C is our answer here. Okay, thanks for tuning in.